Hello all, welcome back to the channel and welcome to the course on integral calculus. Recall students, in the last lecture we have studied about the concept of integration by parts, and in the upcoming lecture, in the series lecture, we have solved some problems related to it, right? Now it's time to learn something more new interesting topic, that is called multiple integration by parts. So suppose, consider students the case where we have the case where we have to integrate different functions and they are in a particular order, like if they are in the summation form or in the in the multiplication form. Suppose, let us consider the example. Let us consider this example. Suppose x square plus x times e raised to x. So this integral can be written as x square e raised to x plus x e raised to x. Now if we apply the method of integration by parts here, it becomes too much complicated, right? Because we have to apply the method of parts to each of these function, right? So for that, there is a point of rescue coming in, that is the concept of method of multiple integration by parts. So I hope you understand the concept. Now let us understand the formula for the multiple integration of parts, right? So if there is an integral, namely fx gx dx, right? And this integral is of the form, suppose fx into g1x minus f1 first derivative of x and g2x plus and so on minus 1 raised to power n minus 1 f n minus 1 means that n minus 1 times derivative, right? X into gnx plus minus 1 raised to n integration of fnx and gnx, right? So where if we understand the formula, then this means applies that f dash x here means the tth derivative, right? Tth derivative of fx, and gk of x means kth integration of gx, kth integration of gx, right? So please make a note. Here is a catch. When understanding the concept of multiple integration of parts, it is very much important and we understand that it is only possible when fx is a polynomial function in x. It should be a polynomial of degree 2, degree 3, degree 4 or any polynomial, but it should be a polynomial function of in function x, right? So that should be kept in mind always, right? Now let us understand this more concept by giving an example, right? So the example is, suppose we need to evaluate x cube plus 2x square plus x minus 3 into sine 2x. So here we have fx as this function and gx as sine 2x, right? So using multiple integration by parts, right? So see the formula once again. Let us revisit the formula. So the formula is fx gx dx equals to fx into g1x, right? So first part is fx into g1, matlab derivative of sin 2x, right? So fx means simply x cube plus 2x square plus x minus 3, right? This is fx into g1x means minus cos 2x by 2, right? Then second part comes to the formula minus f1x into g2x, right? Means again second times integration. So minus 3x square plus 4x plus, so it is only x. So this is 1, right? Times second derivative of sine 2x. Second derivative of sine 2x means 2 times derivative 1 upon d square sine 2x, right? Which is sin 2x minus sin 2x divided by 4 minus का, right? Now again plus, the formula gives plus minus 1 raised to n minus 1. So here n is what? N is in this case 3. So here this is 6x plus 4 f3x, right? Minus 1 n minus 1 means 4 minus 1 3. So this is fx, right? So minus 1 times fn minus 1x. So f3x is 6x plus 4, right? 6x plus 4 times fourth derivative cos 2x by 8 minus according to the formula it gave minus 1 raised to n, and minus 1 raised to n fn, so minus 1 raised to 4 is plus 4 1, and fn x gn x, right? So minus 3 by 4 integration cos 2x, right? So this is the case. Now if we simplify the above expression, then we get to know that it is minus x cube by 2 minus x square plus x by 4 plus 2 cos 2x plus sin 2x. Again integration of cos 2x is minus sin 2x by 2, right? So sin 2x 3 by 4 x square plus x minus 1 by 8 plus ka c. So if you simplify the above expression, then we get to know this part. Now it is your homework, students, and please try it by yourself. Then try to compare the result with the individual by parts method. So what we have to do, you have to apply for not this function. The question is this one, right? So for this question, you have to apply it as like x cube sin 2x plus 2x square sin 2x plus x sin 2x minus 3. So you can see now that how much complexity it would be done if we apply for each of the parts separate integration by parts. So for that method there is a rescue coming in, and the rescue is we have to simply apply the formula of multiple integration by parts. In this way we have simplified the solution. So I hope you understand the topic very much clearly. Let us try and understand more by solving the above problem. So x square plus x e raised to x, right? Now x square plus x into e raised to x. So I will be solving it by normal method. Then you have to homework is to apply the methods of integration by parts. So x square e raised to x plus integration x e raised to x dx, right? So first let us solve I1 as x square e raised to x. So this will become, this is the first function and this is the second function. So first function remains, sorry, this is the first function and this is the second function. So first function remains same, second function integration minus integration differentiation of first function into integration of second function dx, right? Now if we take x square e raised to x minus 2 x e raised to x dx, right? Okay, and we have plus x e raised to x dx. So for that, if we simplify it, we got minus x e raised to x dx, right? So now we have to only solve x square e raised to x minus, what will we need to do? We need to integrate this by parts again. So first function same, second function का integration minus differentiation integration differentiation of first function, that is 1 into integration of second function dx, right? So again we need to know x square e raised to x minus x e raised to x minus e raised to x So from that e raised to x common, x square minus x minus 1. So here we got the answer. So basically this is the longer method. We can also do it by integration of parts, which is the crux of our lecture. We have understand the concept called multiple integration of parts, so and which is the core concept. So you can apply here also and try to solve the problem. I hope you understand the lecture. If you understand, then keep subscribing the channel and press the bell icon for more updates. Thank you so much and have a nice day.